Welcome to the CIS 4190/5190 final project by Angelina Wan, Kevin Ma, and Claudia Polina. The focus of this project is to predict a user's MBTI personality using a list of their preferred songs. The goal is to find a correlation between personality and interest in songs. With that being said, let's slowly discuss some of the past work that is done on this topic. There have been a lot of articles that attempt to link personality and personality. However, the one that we'll be referencing the most within this project, and the one from which we've inspired a lot of our methodologies, is this article, Personality Detection in Music, which attempts to find a correlation between a user's Big 5 personality traits and their preferred songs by training multiple machine learning models like random forest, neural networks, linear regression to predict what their Big 5 traits are. Our project is going to be using a lot of similar methodologies to this paper, and in this video, along with our project write-up, we'll be discussing how we improve upon those methodologies. These are our imports that we use for this project to train our models, and with that being said, let's dive into the dataset that we're going to be using to train our machine learning models. This is the dataset that we're going to be training our machine learning models on. It comes from a Kaggle Spotify MBTI playlist dataset that contains playlists for each of the 16 MBTI types. You can see that for each MBTI type, there is a .csv file that contains a list of playlists tailored towards that personality type, and each playlist contains a multitude of songs, with each song containing numerical ratings defined by Spotify, such as danceability, energy, and whatnot. In our project, we have parsed down all of these files and presented them in a form like this, where each dataset contains the average of the songs within its frame. So we have danceability mean, energy mean, loudness mean, mode mean, speechiness mean, and this is going to be the numbers that are correlated to each MBTI type. With that being said, let's talk about some of the diagnostics and analytics we ran on this dataset before we even began training machine learning models on it. Looking at the data, the first thing we did was plot each distribution for each feature grouped by MBTI. You can see on our exploratory data analysis, in the following plots, we have loudness, mode, danceability, energy, plotted out for each MBTI. You can see that the curve for each MBTI is distinct and unique from each other, implying that there is some sort of correlation between personality and preference in music type. We run some key observations from this data analysis. For example, we highlight that MBTI types like ENFP and ESFP often associate with higher levels of extroversion and show a preference for music with higher danceability and energy. If you want to learn more about these key observations, they're in our Google Colab notebook if you want to read over all of them. Besides that, we also have a violin plot for the distributions for every feature. Once again, the key observations are down below, and we also have a heat map displaying how correlated each feature is with each other. For example, songs with high danceability will often have a high valence, and using this information, we can once again take away a lot of key highlights that you can read about in our Google Colab notebook. Now, before we start training our machine learning models, the first thing we need to do is start by creating and sorting our features. So in the Personality Detection in Music article, they ran acoustics on the Big 5 data personalities. We are going to be doing a similar thing with the 4 independent attributes of MBTI, that being introversion versus extroversion, N versus S, T versus F, and J versus P. Besides this, we're also going to be doing a more holistic review, seeing if we can guess the entire MBTI instead of just independent attributes of it. So with that being said, in our feature engineering, you're going to see 5 blocks of code. This is going to be the label mapping for independent MBTIs. You can see that every MBTI has its own independent label. Here we're splitting it into I or E. You can notice that all of the I's are 0 and all the E's are 1. This is splitting N and S. This is splitting T and F. And this is splitting P and J. We are scaling all of them using a standard scaler. We have a different data set for each model. So we have the introversion versus extroversion training set, the N versus S training set, and so forth. So when it comes down to it, we have 5 different training sets that we're going to be running our models on. So when it comes to actually training our models, we're going to be using 3 models of machine learning to see how well each of them stacks up against predicting MBTI. The three models we're going to be using are logistic regression, random forest, and finally multi-class neural networks. Let's start talking about the first one, which is logistic regression. We're going to be running it on all 5 of our data sets. So you can see on the first dataset where we try to predict all 5 features or all 4 features of the MBTI, we can achieve a cross-validation score of 0.233 or 23.3%, which admittedly is not incredibly high, but considering that if you were to take a random stab at an MBTI, there are 16 of them, you would have roughly a 6% chance of getting it correct. We think it is a statistically significant result. With that being said, though, when we move over to independent MBTI traits, we can see that cross-validation accuracy score rise significantly. For example, for predicting introversion versus extroversion, we have a 71.5% cross-validation score. For N versus S, we have a 58%. For T versus F, we have a 70.8%, and for P versus J, we have a 60.5%. Down in this plot, you can see the accuracies of all of our predictions. You'll notice that the MBTI total has a much lower accuracy, but that is expected since we are predicting all 4 aspects of the personality instead of only one. It is also important to note that if we were to independently multiply the percentages of getting all 4 of these attributes correct, it would be lower than this training accuracy reported by the complete set of 4 traits, indicating that there is some sort of correlation between independent MBTI attributes. Additionally, here are the logistic regression coefficients we've got after training our model on the full 4-feature MBTI. And here is the receiver operating characteristic for each of the 16 MBTI classes. Once again, you can check out our Google Colab to read any of the analysis we've done on the results of these tables. Moving on to our second model, which would be random forest. This was actually our best performing model. Let's quickly go over its accuracies in each of the 5 different categories. So when trying to predict the entire MBTI, it received a 26.9% accuracy. For I versus E, it had 73.7%. For N versus S, it had 22.7%. For T versus F, it had 72.3%. For P versus J, it had 63.26%. And here, once again, you can see a plot finding the accuracy of random forest on all of our MBTI attributes. Additionally, we ran diagnostics finding out which features were most important. Here you can see a plot describing feature importance. You can see that features like valence or instrumentalness are more important in deciding what MBTI you are over features like tempo or liveliness. Now let's talk about the last machine learning model that we've decided to use, neural networks. For our project, we're using multi-layer perceptual classifiers. And one important thing to note is the initial learning rates as well as the max iterations. Both of these were adjusted during our project such that the models could be trained in a realistic time frame. It is possible that if max iterations was increased or if the initial learning rates were decreased, we would see higher cross-validation accuracy, perhaps surpassing that of random forest. But nonetheless, here are the accuracies that we got for our training models with these initialization values. So for the full MBTI, we have a 25.3% validation. For I versus E, we have 73.2%. For N versus S, we have 60.1%. For T versus F, we have 70.9%. And for P versus J, we have 63%. Once again, a diagram is provided detailing the accuracy of multi-class neural networks on all of our MBTI attributes. Now let's talk about some of the contributions made by our project. And the first one is actually something that we haven't talked about yet. The first contribution we attempted to make was towards data collection. Before we resorted to the Kaggle dataset, we actually created a survey asking about respondents' MBTI type as well as their preferred genres of music. You can see this Qualtrics survey that we created asking for a person's MBTI as well as the specific percentages they had on their MBTI and correlated that with their favorite genres of music ranked in a list. Unfortunately, this survey didn't get enough responses. As of recording this video, it has 40 recorded responses, which was not enough to train a machine learning model off of it. We think that this is due to a lack of incentive for respondents to fill out the survey, so this is definitely an important consideration that we're going to be taking into the future. Our second contribution lies in the improvement in the methodologies over the article Personality Detection in Music that I talked about earlier. Here you can see the results found in their experimentation where they tried to train multiple machine learning models to try and find the big 5 personality traits of a respondent based off their musical tastes. Looking at the averages across their models, we can see that their mean scores lie around the 25% range, with their best scores lying around the 40% range. In contrast, our models have about a 70% accuracy in predicting independent MBTI values, and when it comes to overall MBTI values, we have about a 25% of predicting that. We think that the main reason why we had a higher validation accuracy score is because we were able to resolve one of the key flaws in the personality detection in music experiment, which they point out themselves. They admit that the problem with their experiment was that their database was poorly balanced. Basically, they sent out a survey, but when respondents filled out the survey, they found that they had missing values in a lot of their targets. The way we solve this is by using the Spotify Kaggle dataset, which pulls data directly from Spotify, meaning that there are no missing or null values, which allowed us to have a more balanced dataset compared to the dataset used in personality detection in music. We believe that was the critical difference when it comes to gaining higher training scores. Outside of our major contributions, we feel like we were also able to make minor contributions in the area of data analysis, pointing out relationships between MBTI and song preferences through our visual data plots and feature maps. But at the end of the day, we were really just having fun training these machine learning models in an area and field where we had a strong joint interest. And that's going to wrap up the video presentation of the CIS 4190/5190 project by Angelina Wan, Kevin Ma, and Claudia Polina. We hope you had a wonderful time and perhaps learned something new about your personality or your preferred songs through this project, and we hope you have a lovely day.